Here we're going to look at question 20 from section 2 of the BMAT 2014 paper. So in this question we're given the following diagram of a structure which has a square base where each side has a length of 1 metre, and then at this point P we go vertically up to this point X, which is 4 metres directly above it, and then X is connected to each of the 4 corners of our square base. So what the question asks us is to find the cosine of the angle that this distance XR makes with the horizontal. So this distance from X to the side of the triangle opposite to P. So if you'd like to have a go at this question yourself, then just please pause the video now. Otherwise, let's have a go at it together. Okay, so to do this question, let's first of all think about what we're actually being asked, the cosine of the angle that XR makes with the horizontal. Well, what actually is that? So the horizontal is just going to be going across the way, and it's the angle that XR makes with the horizontal. So we could say that we could draw a horizontal up at X, and it's going to be the angle in there, or we could do the same thing at R down here at the bottom. Now I'm going to choose this way down at the bottom because I think it's a bit easier to visualise what's going on, but you'd be just as well to do it up here at the top and find the angle in there. So what we can now do is we label on this extra side, going from R to P. And we already have our length of R up to X, so we could call these two some different variables, such as X and Y. In which case, the cos of our angle theta, the cos of the angle we're trying to find, is just going to be equal to X over Y, the adjacent over the hypotenuse. So to find cos of theta, we need to find both X and Y. Right, so let's try and think of some ways that we can find X first of all. Well, if we look at our diagram, then we can see that X is just the diagonal across a square. So it actually makes up the hypotenuse of this right-angled triangle here, which has the other lengths being 1 metre. So we could just use some Pythagoras to try and find X squared, giving us that X squared is equal to 1 squared plus 1 squared, which is X squared equal to 2, or X equals root 2. So that was fairly easy. We could now go ahead though and look for our value Y. Now Y might seem a little bit trickier to see at first. However, it is actually going to make up one of the sides of another triangle, going from R across this distance X to P, and then up to X, this point X here. So this triangle from R to P, X, and then back is going to be a nice triangle. It's going to be right angled as well, since this distance PX is just vertical. So we could just use some Pythagoras again to find the hypotenuse Y, giving us that Y squared is equal to our X squared plus 4 squared. Then we just found out that X squared equals 2, so we can substitute this in, giving us that Y squared is equal to 18, or the Y equals the square root of 18, which is the same thing as 3 root 2. So with our values of X and Y, we can just substitute them into our original expression for cos theta, giving us that cos theta is equal to root 2 over 3 root 2, and of course our root 2's just cancel, giving us a final answer of a third, which is going to correspond to A given in the question.